sine theta, negative cosine theta, but in 1 and in 2 has theta 1 and theta 2 as well.
Right,
Okay.
correct,
Gotcha.
correct,
Okay.
correct. So I don't know, I think this is one of the most profound and really quantum, like this is deeply quantum. And this has, so this is called one of the no-go theorems. There are other theorems that were developed since John's bells, but this is the most foundational and the most famous one. And there is a whole branch of people who study other no-go's theorems. So they study that, they dedicate their careers. So they, I don't know if you heard of the expression GPT. No, it's not the chat GPT. It's the acronym for generalized probability theories. It is not a generalization of probability theory. It's a terrible misnomer. It is a theory about measurements and it's a theory about measurements and causal models. So they study a bunch of different causal models and generalizations of quantum theory and see what kind of no-go theorems apply to each of these generalizations. What they're trying to do is trying to say, well, is there a generalization of quantum theory that is compatible with the experiment and which I can know the causal structure? And I think the big name that comes to my mind when I think of this field is Rob Speckings and his group. But there are others. There are people in Vienna also doing similar activities. Anyway, so this is clearly, well, we'll have to live with that. So if that's one of the reasons why I originally wanted to have the debate later in the semester, because if you believe in, that team modelist paper that I mentioned, the 3 measurement problems, one was that all the information is contained in wave functions. And now I understand that it's even more restrained than that. Because if you believe in these models in which you're violating all information is contained in the wave function, these violations can't be of this type. They have to be non-local in a sense. Now, it's sometimes, so there are many interpretations. People dispute about this. There are disputes about the interpretation of that. So one of that is called realism. So you can decline that these lambdas exist altogether. This is an option as well. And it's also easily forgotten. John Bell had a strong bias in favor of realism. So that's why he coined beables and so on. So if you decide to emphasize the non-local aspect of the realism aspect, it's about a bit up to you. But well, there's a lot written about that. But that's all I had to say about that. See you on Wednesday.